actual Rankine cycle. Okay. Using the same problem, okay? Ibigay ko sa inyo. Same yung problem natin ha. Para mas maintindihan si actual Rankine cycle. Okay, mahaba-haba to. 100 megawatt steam power plant. Ma'am, paano yan parehas si Eva? Okay. The rates on the Rankine cycle, but with the turbine and pump efficiencies of 85%.
Palayo mo yung charge, walang battery ka. Ginamit mo.
Ay!
Dito ginamit.
Diri!
Kaya ayaw siya, base ni Kuya.
Oo! Kahit tinisting niya to.
Sana.
Okay, so this is now the actual Rankine cycle. So we have a 100 megawatt steam power plant operates on the Rankine cycle, but with the turbine and pump efficiency of 85%. The steam enters the turbine at 7 megapascal and 550 degrees Celsius. It discharges to the condenser at 20. So same yung given ha. Ibig sabihin hindi na tayo hanap ng properties. Yan. 550, 20. Pero may iba na given. Okay? So, anong happen? So, determine now the cycle thermal efficiency. And we have here the steam flow rate. Yan. The cooling water flow rate in the condenser. Ayan. If given sa atin yung cooling water properties, ayan, enters at 20 degree and leaves at 35 degrees Celsius. Okay. Yan same lang sa atin, but ano yung mga additional given sa atin? We have the turbine pump efficiency is 85%. Sinabi parehas na 85% and pinapahanap sa atin cycle thermal, the steam flow rate, and the cooling water rate. Given sa atin yung entering water and the leaving water. Okay? Leaving temperature of the water. Okay? To represent this, ayan, black. Ulitin ko lang yung schematic diagram natin. We have the boiler. We have the turbine. Ayan. All throughout this year's class, parang masasaulo nyo na to. Ayan. More work sa turbine, shaft work. And meron tayo electricity dito generated point 1 to point 2, we have now the liit ng condenser. Yan. Condenser. After that, we have the pump. Practice more class para matrain kayo. Okay? So, this is the turbine. Turbine natin. Condenser. This is the cooling water. The pump. Yan. Ano meron sa boiler? We have the heat addition, work turbine, heat rejection. Right. Heat QR, my work of the pump. Ayan. So, take note. Ano yung bagong given sa atin? We have now the efficiency of the turbine at 85%. The efficiency of the pump at 85%. Ano yung magbabago nating properties from point 1 to 3 to 4. So, magkakaroon na tayo ng 2 prime here. That is now your actual dahil sa pump efficiency, turbine efficiency. After that, magkakaroon din tayong 4 prime dahil sa pump efficiency. Okay. Intindihan? After this, you draw now the TS diagram. Yan. TS diagram mo. Gutom yung TS. Wait. We have now your TS diagram. Walang pinagbago. Okay. Anong mangyayari? Kanina ganito yung graph natin. From point 1 to point 2. Yan. You know. Okay, we have point 1, point 2, 3, and 4. Ito yung kanina. Since given na sa atin yung efficiency niya, so hindi natin alam kung saan magpo-fall siya, kung nasa wet region pa ba. Ito yung magiging dalawang option mo. Pwede dito pa rin siya sa loob or dito sa labas. Okay? Yan. And this one. The 4 prime. Yan. Sa labas talaga siya. Okay? So, we proceed now. Given sa atin yung 7 MPa and the 20 kilopascal. Okay. Ano yung una mong gagawin? We have this. We have also the entering temperature of water. Nakalimutan ko. And the living condition. Tama ba? 35. Yan. Yan. So, this is the actual Rankine cycle. So, ano yung una mong gagawin? Okay. We need to determine now the actual enthalpies of the cycle. Okay, so alam naman natin na given na sa atin yung pump efficiency. Okay, pump efficiency 59 kayo. Okay, using that, this is class the formula in the turbine efficiency. Okay, so sa turbine efficiency, that is the actual work of the turbine over the idea of work. The turbine. Compared to the pump efficiency, that is now the ideal work of the pump all over the actual work. Yan. So, minsan kasi ginagawan ko to ng acronym. This is TIE and this is PIA. Okay? So, turbine efficiency, actual over the ideal, and the pump of the work, ideal over the actual. Okay? Paano po yun, ma'am? Punta na tayo doon. In solving the problem, given sa atin yung pump efficiency, turbine, 85%. Okay. Hahanapin natin si H2 prime using the turbine efficiency. Okay. And yung H4 prime natin using the pump efficiency. Ano yung gagawin mo? We all know that the pump of the turbine, punta muna tayo sa turbine. Turbine. Okay. Di ba alam natin that the work of the turbine, yung ideal, we have H1 minus H2. Sa pump natin, we have H4 minus H3. Pero hindi naman talaga to yung ginagamit natin. Pag nakukuha tayo ng work of the pump, we make use of this one. Okay. But since we have now the actual, in the actual Rankine cycle, maulan class. Okay. Ito muna yung gagamitin natin when given sa atin yung efficiencies. Okay. So, turbine tayo, focus. So, turbine work is equal to the actual. What is the actual class? So, H1 minus H2 prime over the ideal H1 minus the H2. While here in the pump work, ideal over the actual. Ano yung ideal natin? H4 minus H3 over the H4 prime minus H2. Okay. Computing for H2 prime, we have, ano yung gagawin ko nga? Shift solve nyo na lang class, 85%. Ano yung H1 natin? Balik ulit tayo doon sa problem number 1. Ay, sinulat ko na yun. 35. Ayan. Ito na, may work of the turbine tayo. Gamitin na natin to. 1241.22. 1241.22. Baka tanongin niyo ako kung saan ko yung kinuha. H1 natin, 3530.9. H2 prime. What is now your H2 prime? This is equivalent to work of the turbine. Plus your H2 prime. Si mom, di nga sa mo turo. Ayan. 35, 30.9 minus alpha. Alpha X. What is now your X? Nakuha ko na. What is your answer, class? Okay? 2,475.86 kilojoule per kilogram. We have now here, okay, ano yung sunod natin kukunin? Yan, we have now the H2 prime. The H4 prime. We have now the pump efficiency. That is equal to H4 minus H3. H4 prime minus H2. 85 then, as stated in the problem, H4 minus H3. This is equal to, saan na? Homework of the pump, 7.1 H4 prime. Ano yung H3 natin? Baka malito na kayo 251.4. We have now the H4 prime. What is the H4 prime? Equal to 51.40. What is now your answer? Yung H4 prime. Ano yung answer class? 2. Okay, 259.75 kilojoule per kilogram. We have now the prime. Ma'am, bakit kinuha natin yan? Class, yes. Because it will affect now the work net of the different processes. So, mag-iiba class yung cycle efficiency natin, ha? So, we will now compute for the actual work, which is equal to H1 minus H2 prime. Yan. Okay. Ano yung H1 natin, class? 35, 30.9. What is now the H2 prime? What is now the actual work? Sige nga. Actual work. Work of the turbine. What is now the actual work of the turbine? Can we have it? Anyone? Actual work of the turbine, ma'am, bakit kailangan natin? Isa lang nag-compute? Okay. The other people. Nasaan na yung iba? Okay. Three, 1,000 ano? 1,000 ano yung iba? We have now 35, 30.9. We have now 1,055.04. Tama ba yung sagot nyo? Okay. Kilojoule per kilogram. We will also compute for the actual pump work. We have the H4 prime minus H3. So, 59.75 minus yung H3 natin. Ito yung H3 natin. 251.4. Sige, paki-compute niya for the pump work. What is now the pump work? We have 8 point 8.35 kilojoule per kilogram. Okay. So in computing for the cycle efficiency, we always compute for the work net and the boiler over the heat added in the boiler. Okay. So we have H1 we have now the heat added. Okay, so boiler class. Yung boiler natin entering is 4 prime now and 1. Heat added. H1 actual. H1 minus H4. So the heat added now, H1 natin is 35.9. H4 prime natin is 259. What is now the boiler? The actual heat added in the boiler? 3530.9. What is your answer? Ano class? May mali ba? 35, 30. 35, 30 baga class? Ano yun class? May mali ba? Oh, wait. Okay. 37 ba? Bakit 37? Ano yun class? May makita akong iba. Okay. We have now through to 71.15 kilojoule per kilogram. Okay. Finding for the in an actual Rankine cycle, we compute now for the actual thermal efficiency. So you go to the work net over the heat added, work of the turbine minus work of the pump, actual heat added. Finding for the actual, we compute now turbine 1055 0.04 kilojoule per kilogram. Work ng pump, 8.35 kilojoule per kilogram. Divided by the heat added. So we have now the actual thermal efficiency. Milan. Given yung mga different pump efficiencies, we can now compute for the cycle efficiency. 8, or this is just equal to have now the cycle efficiency at 32%. Okay, may 1 point na tayo. The next question now, given sa atin yung steam flow rate, given sa atin class is the 100 megawatt steam. Okay? And finding for the flow rate of the steam. Okay, paano yun? Given sa atin sa problem the 100 megawatt, so that is the total net power. Yan. Yan yung na-produce. Okay. Finding for that mass of the steam, MP. Kadalasan. Sige, MS na lang. Excuse me. Mass of steam. Pag-given na sa atin to class, ito na. Over that is divided by the network. Per unit mass. Ito yung actual kasi given naman sa problem. So we have 1,000 megawatt. So in kilojoules, that is like this, kilojoule per second. Joule per second is in watt. Over the actual, this is the work net. Ito ay hindi ko pala ito na. Okay, hanapin nyo kasi yung work net natin. What is the work net? So, ilan may nag-chat ba? Kilojoule per second over. Yan yung work net natin. 55. 1046.69. Okay. So, we have the mass of the flow rate or yung steam natin. Flow rate of the steam divided by the 1069. We have 95 point. Ano yung answer niya? 54 kilogram per second. Kilojoule per second. The reciprocal. Kilojoule. Cancel. Kilogram per second. So we have now, pangalawa, we have now the mass of steam. Okay. Going back, na yung pangatlong tanong sa atin, determine the cycle, the flow rate. Ayan, cooling water rate, condenser cooling water enters at 20 and leaves at 35. Okay. So, first law, analysis, the condenser. So, ito yung condenser natin. Yan. Entering 20, leaving 35. Okay, H2, H3 may heat, rejected. We all know that heat rejected is just equal to the MCP, the mass of the water. Okay? Ay, may actual pala to class. Nakalimutan ko yung actual. Okay? We proceed yung heat rejected natin since given na yung mass of the steam equal siya sa H3 prime minus the H4. Bakit H4? Bakit H3? Mali. Ah! Okay. Tama ba? H2, 2 and 3 sa condenser. 2 prime 3. 2 prime. Baliktad para si ma'am. Yan, double check nyo class. Para hindi kayo malito, we have the H2 prime, H3. Okay. So, now the mass of steam. Nilagyan ko lang to kasi magiging kilojoule na yan. Ngayon, we have the H2 prime minus the H3. Okay. So, sa heat rejected class, equal naman na siya ng energy sa mass of the, kasi pinapanap sa atin is the mass of the water leaving, mass of the cooling water, and equal siya sa H ng leaving na water minus entering na water. Paano natin yun makukuha? Because given sa atin yung, ano yung entering natin class? Saturated liquid. Saturated liquid at entering temperature which is equal to 20 degree. Punta ka sa 20 degrees Celsius. Kasi water naman siya, you can use the steam table. Kasi steam ba class galing sa tubig. Table 1. Page 2. We have now HF at 20 degree. Kasi saturated liquid naman talaga siya. We have 83.96 kilojoule per kilogram. And also the saturated liquid at leaving temperature which is equal to 35. So 35 degree. Same page. Table 1, page 2. We have HF at 35. That is 146.68 kilogram. Okay. So by energy equation, entering is just equal to leaving. So the heat rejected, kasi kung ano yung pumasok class, yun din magiging energy na lumalabas na tubig. So we have the mass of steam now. We have H2 prime minus H3. equal siya sa mass MC, that is the mass of the cooling water. Yeah. H na out minus the in. Okay. So, the mass of steam, pinapahanap sa atin is the mass of the cooling water. Yeah. What is the mass of steam? 95.54. H2 prime. Binaw ko ng class. H2 prime. Haba. Masaan na? Ayan. 2475.86. Minus, what is H3? H3. Yan. Sana yan, H3. Kung mali ka dito pa sa isa, mali ka na sa lahat. H3, 251.4. Kaya class, pag nagsusulat ng solution sa termo, di namin inaalaw na magsulat sa likod ng papel. Lahat paunahan. Sa unahan lang. Okay. H out. Ano yung out natin? 146. In is 83.96. We have now the mass of the cooling water. Yan. Bus na. 930. Okay. What is the mass of the cooling water? Yan. Bilisan ko kasi may next subject para makapahinga. 75.86 minus 251.4. Ta-da! Divided by 146.68. 83.96. Yeah. We have now the mass of the cooling water. Oh, paano yun, ma'am? Ganito para mas maintindihan. The answer now is 3388.47. Ano yung magiging unit mo? Okay. Ito class, sa taas. Yung sa taas, steam. That is kilogram steam per second times kilojoule per kilogram of steam. Diba? Yung sa taas. Sa baba naman class, times H. Sa baba, we have kilojoule. Kilojoule per kilogram of, hindi na siya steam, water. Okay. Kakancel yung kilogram of steam mo. Cancel yung kilojoule. So, matitira na is yung kilogram of water per second. So, yung unit natin dito is kilogram of water per seconds. That is just in kilograms. Okay? Okay? Naintindihan ba? So, this is the actual Rankine cycle. Okay. Pag mali ka sa pinakaunahan, mali ka sa pinakahulihan. Double check. Wala pa tong double interpolation. Okay, class. So that is the example problem of an actual Rankine cycle. Yan, mas mahirap kung wala kasing problem na sinusolve sa actual Rankine cycle. Okay? So, if you have any problem, concern, anything, just PM ma'am. I-chat nyo na lang si ma'am. Okay, ito. So, paano natin mako-consider if sa labas or sa loob yung actual efficiency natin? I mean, yung 2 prime natin. Sige nga. Ano nakuha natin? Yung H2 prime natin is 2475. Okay. From the steam table, ano yung una nating value sa H2? H2. Ano yung quality niya? H2. Ay, wala pala. Hindi pala pinakita dito. At ano na? Dito na lang. So, punta ka doon sa same pressure at point 2, 0.02 MPa. Tingnan mo yung Hg doon. Na, yun na page. Page. Saturate 0.02. Page 8. Yung Hg natin is Hg is 2609.7 kilojoule per. Ibig sabihin, class, nasa loob pa rin yung H2 natin. H2 prime. Ibig sabihin, here class, so dito pa rin siya. Yung 2 prime natin, from the problem, magiging ito. So, dito. Yan. Sa loob pa rin. Katabi ng this is now your 2 prime. Okay? Paano kung pinapahanap ko sa what is now the quality at this point? Yan. Paano mo yung solve yung x2 prime natin? Okay? So, balikan mo lang. H2 prime now is equal to HF2 plus the quality at point 2, HFG2. Finding for the quality at that point using the H2 prime. Yan. Same table Page 8, table 2. Yan. Wala to sa problem pero pinapakita ko lang sa inyo. H2 prime. Ano yung H2 natin? 2475.86. HF2 251.4 divided by HF 2358.3. Yan. Wala sa problem pero pag pinahanap ko, this is now your quality at that point 2. What is now your answer? 275.86 minus 251. Excuse me. 2358.3. Oh, diba? So, it falls again into the mixture. Ano class? Ano po ang answer nyo? At this state. What is your answer? What is the quality? Okay. We have 94.32%. So that is now your quality at point 2. At the actual Rankine cycle. Okay? So, yan, mas mataas siya. Di ba? Ano yung una natin na quality? Dito. Nakuha natin is 86. So, from 86, dito yung 2 natin, 86.43 naging 94.32%. So, that is now your actual quality at point 2. Okay? Yan. So, what is the secreto in solving this? Okay. Pag mali ka sa pinakataas, magiging mali lahat ng sagot mo. Lalo kung mali yung conversion mo. Okay? Into kilopascal to megapascal. Okay? So if you have more question, then PM ma'am. PM na lang si ma'am. Okay? Para maka-ready na kayo sa next subject. Yeah. Okay? So that is now the actual Rankine cycle. Naintindihan ba, class? So you need to not familiarize, but you just need to analyze the problem and take note that the turbine, the condenser, the pump, and the boiler are always or the fundamental in a steam power plant. Okay? Question? Okay, raise your hand if you understand now the actual and the ideal ng Rankine cycle. Ang ideal, madali lang. Ayan yung ideal. Ayan yung ideal. Okay? So, if you understand it all, can I request everyone